Hi everybody. In this video I'm going to show you how to do t-tests and interpret them in JASP. So I opened up JASP and I clicked on this little 3-line thing, say open, recent files, stats practice data. Brings up this data set and I'm going to go to t-tests. And in this video I'm going to show you how to do independent t-tests and paired t-tests. So first, the independent t-test. We need one dependent variable that is measured on a continuous scale. So let's look at something like, let's look at how about valuing school, something like that. Dependent variable valuing school. And let's say our independent variable, this is a problem with JASP, is the only independent variables that'll let you use are dichotomous variables, categorical variables with only 2 categories. Other programs will let you pick like a 4-category variable, but then pick 2 categories within that. JASP doesn't. It's got to be a 2-category variable. So let's go with gender and let's take a look and see what we get. Down here is different options you can choose. So over here we see we already have a t value, which is not statistically significant. So we know there's no difference between males and females in these samples in how much they value school. But let's get a little bit more information so we can look at descriptives. This will show us the means and the standard deviations and the sample sizes. And let's look at effect size. Okay, so let's walk through this. First, this is our t-value for our independent t-test. Our degrees of freedom is 824. So that tells us there's 826 cases. And we can look down here at the sample sizes, and if we add those together, it would be 826. Because our degrees of freedom for an independent t-test is the 2 samples added together minus 2. P-value shows it's not statistically significant. And if we look at the means, we can see the means are really, really similar. And as you would expect, when you have a t-value that's not statistically significant, the Cohen's d is really small. So here's what we would say. Our p-value is above 0.05. Therefore, we retain the null hypothesis and conclude there are no differences between the population means of males and females in their valuing of school. Whatever little difference we see between the sample means was too likely to have occurred by chance for us to rule chance out. So, no difference between the population means, and the effect size, as measured by this Cohen's d, is really small. So not only is there no statistical significance, there's also no practical significance of these results. All right, that's how you run an independent t-test in JASP and interpret the results. Now, let's try a paired samples t-test, also known as a dependent samples t-test. And let's see what we get here. For a paired or dependent samples t-test, one of the best uses is to see whether there's a change within the same sample over time on the same variable. So let's take a look at wave 3 math grade. So this was in the spring of the school year. I'm sorry, in the fall of the school year. And then wave 4 math grade would be in the spring of that same school year. So did students' grades change from the end of the first semester to the end of the second semester? That's what these 2 variables are measuring. And what we can see right away is that the t-value is statistically significant. So there's a change in math grade from the end of the first semester to the end of the second semester. It's very handy to be able to actually see the means. And let's look at the effect size as well. Okay, so looking at this now, we see our t-value is statistically significant. Therefore, we reject the null hypothesis, and we conclude that the change over time in average math grade was statistically significant. There's a difference between the end of first semester math grade and the end of second semester math grade in this population. What we see here is that the grades declined. The grades went down. So it looks like math grade went down from the first semester to the second semester. And this Cohen's d of 0.24 is pretty small, so it's not a huge effect size. It's actually a pretty small effect size. So there's statistical significance, but not a ton of practical significance. Now, something over here that's worth noting is that the sample size changed. This is the same group, but not everybody that we got in the first semester participated in the second semester. So I'm not really comparing apples to apples here because the sample, we lost some people, and I want to make sure I'm comparing the same people at each time point. So to do that, I got to go back over here, and you see where it says missing values? I have to do the missing values listwise, meaning any value that's missing at either time 1 or time 2 is going to be taken out of the sample. So when I do that, you'll see this sample size changes and becomes the same. So it's only the same cases that I had grades for at both time points. And here I can see it didn't really change much. It's still statistically significant. The p-value is still very small. The Cohen's d value is just about identical. Just dropped a tiny, no, it didn't drop. It's just about identical to what it was before. And the difference between the means is about the same, about half a point. Okay, so that's how you run t-tests in JASP and interpret the output.